Hey guys, welcome back to General Chemistry. We are going to work another example of those titration problems, as I know they're kind of tricky. Plus, I want you guys to look at one where there's coefficients in the problem as well. So a couple little wrinkles. So here is our problem. So go ahead and pause the video, write down the chemical equation and the problem. All right, so here we've got a 20 ml sample of unknown phosphoric acid, H3PO4, is titrated with a 0.1 molar sodium hydroxide solution. When the equivalence point is reached, 18.45 mils of sodium hydroxide is added. What's the concentration of the H3PO4? So first thing I like to do for titration problems is draw my picture. So here's my burette. Here is my flask. In my burette goes my known. In my flask goes my unknown. Okay. Read back through the problem and put things where they belong. Right, a 20 ml sample of unknown H3PO4. So that is pretty clear which one the unknown is. So the unknown is H3PO4. And it says we started with a 20 ml sample, so I'm going to put that down here. Is titrated with 0.1 molar sodium hydroxide. So I know the concentration. I know what it is. Now I just need to get the volume. So the equivalence point is reached when 18.45 mils is added. Excellent. Okay. Now we have our picture. Now we just need to plug through our mantra here. So molarity, moles, molarity. Just as a reminder, molarity is this equation, and we're going to deal with our known first. Moles, we're using our mole to mole ratio, so we're going to go from moles of known to moles of unknown. All right, and then for the last piece, we're going to, again, use the molarity equation. And this time we're going to be dealing with our unknown. Okay, beautiful. All right, so let's start first with molarity. So we have our equation, molarity, moles, volume. Okay. So we're starting with our known solution. So we do, in fact, know the molarity of this solution. So again, it's 0.1 molar. No mention of the number of moles. But we also know exactly how much we put in once that equivalence point was reached. Biggest mistake here is students forget to put it into liters. So for volume, it's going to be 0.01845 liters. Okay. So now we plug that into our equation and chug through it. So I erase it just because I run out of room. I suspect you're going to just keep working on your paper. So 0.1 molar, number of moles on top, 0.01845 liters on the bottom. Okay. All right, so just an algebraic rearrangement. I want to multiply by my liters to get that out from my fraction. Whatever I do to the right side, I also have to do to the left side. So in this case, our number of moles equals, we take 0.01845 times 0.1, and we get 0.0018. We'll just call it 5. We'll round a little bit here. And that is moles of NaOH. Okay. Step 1 is done. Step 2, we are going to go from our moles of known to moles of unknown using stoichiometry. So that's that mole to mole step. Okay. So I'm going to take the information from step 1 and I'm going to start my train track. And little to no thought, moles of NaOH goes on the bottom because that's the unit that we're trying to get rid of. Now we go back to our equation, our problem, and NaOH was our known. Our unknown was the H3PO4. So let's go ahead and put that on top. So this was that mole to mole ratio using the balanced chemical equation. So now we need to go back to the equation and determine what the coefficients are. So looking at our balanced chemical equation, I see that there's a coefficient of 3 attached to sodium hydroxide. So when I do this mole to mole step, I need to make sure 3 stays with sodium hydroxide. And looking at our balanced chemical equation, there's a coefficient of 1 in front of our H3PO4. So I need to make sure that coefficient of 1 stays with the H3PO4. All right, now to solve, we multiply across the top and divide by the bottom. So we've got 0.00185 times 1 divided by 3, and we get 6.1, and my calculator just put it into exponents, and that is moles of H3PO4. I think I wrote this wrong. Typed it into my calculator correctly. Just forgot that 0. Okay. All right, so we've got molarity, check, moles, check. Now we need to go back to that molarity equation so we can figure out what is the concentration of our unknown solution. So we go back to the molarity equation. We take inventory of each piece. Okay. Molarity, well, that's literally what we're trying to solve for. What's the concentration? Number of moles, that's what we solve for in step 2. And volume, of course, we know exactly how much of our unknown that we start with. We can measure that out. Again, making sure that this is in liters. Okay. So plug and chug from here. So I'm going to plug it into the equation, chug through it. Molarity equals number of moles divided by the volume in liters. So the molarity of the H3PO4 is 6.16 times 10 to the negative 4 divided by 0.02, and it is 0.03 molar. Okay. That is a titration problem. The wrinkle that introduced itself in this example was the fact that it was not a 1-to-1 ratio, that there was a coefficient, so that mole-to-mole step became vitally important. I hope you guys found this helpful.